So I'll be perfectly honest with you. I sometimes disparage about the term digital twin because it's used to cover a multitude of sins. And I'm not saying it's wrong. I have not been able to come up with a better term, so I'm stuck with it, I'm afraid. But in terms of the industrial gas arena, and especially things like LNG, natural gas production offshore, onshore, shale gas, the whole thing, it's about understanding that the digital twin, what I personally call the engineering digital twin, how it affects the operational digital twin. And it's about how you actually integrate the two together, because you in the engineering digital twin define the operating envelope. Okay, that's the physical envelope in which you're going to operate. And if you're going to operate efficiently and sustainably, you have to minimize energy consumption, minimize emissions, etc. The operational digital twin has to align with that engineering digital twin and work in harmony. Now, that is the approach that we're taking here at AVEVA, and that is how our customers are actually now changing their approach to their engineering procurement contractors. They're actually saying to them, I want your engineering digital twin. I want that delivered. That's my deliverable, along with the plant, but you need to give me the operational side as well. And that's about the process data. It's about having the process data aligned with the operational data. And you've got to go beyond what I call the 4 to 20 approach, the 4 milliamp to 20 milliamp approach. It's not just the plant real-time data. It's the transactional data. It's the instructions that you're given from your ERP system, from your order system, etc., how those fit into the operational environment. And the digital twin allows people to actually work in harmony. And then there's AI to put on top of it. Now, if I extend that forward, and we then look to the extended reality world that we tend to find ourselves in, what we're seeing is there aren't as many people today doing what I would call traditional operator rounds, walking around the plant with a clipboard or if they're lucky enough, a handheld device. So when something is going to happen, the digital twin has to inform people, yeah, there's an issue here, you need to go and look at it. So you then use the extended reality to go and before you go out, understand where everything is, understand what the risks are, do your own risk assessment before you go out. That is the power of XR in the operational environment. But don't forget that if you've got an XR environment in of your plant, that allows you to train people without having them to go outside into a dangerous environment. They can actually walk the plant. They can understand what happens. You can actually set up training programs with your operators, your panel operators, whereby you can actually walk through specific exercises. And that is a real benefit. This visual understanding of how the plant works is really, really important, especially because plants today do not have access to experienced people. You've got to generate that experience yourself. How do you do it if you've got nobody to teach? You've got to build that teaching environment into that XR environment. And that is where the power of XR is really coming to the fore. And we're seeing that in a number of cases, like industrial companies like BASF. We're seeing it in new hydrogen plants as well, because there are no experienced hydrogen electrolyzer plant operators out there. They want to know what's happening as well. And this is going to extend, I think, in time to to drone operators and things like that. And that again gets back into the whole AI environment, I think, as well.